Define the ratio of reflected to internal intensity as the following equation. So, the most difficult equation that you'll probably do in this topic, and it's the one of only two equations, so we're pretty much done in mathematics. When ultrasound waves pass from one medium into another, such as bone into a muscle, the amount of reflection is determined by the difference between the two materials' impedance. We just learned that in 1.4. The greater the difference in the impedance, the greater the percentage of the wave that is being reflected. But however, some of the lower percentage of the wave is still being refracted. So when the wave hits a surface that is perpendicular to the transducer head, the reflected wave is picked up by the piezoelectric crystal in the transducer. The ratio of the reflected intensity to the initial intensity is given by the following equation. And you might want to copy that down for your books. Okay. If the ratio of intensity is close to 1, the boundary between the different tissues is easy to identify to an ultrasound scan. However, if the intensity is close to 0, then the boundary will not be clearly defined and will be difficult to identify. Okay, so the key thing is here is copying down that formula with the different variables in your books and maybe highlighting that, but also the first sentence, so looking at the two different impedance of the materials. So they'll give us a number, and we want it close to 1 to give us a clear boundary.